In this problem, we're asked to find the number of terms in a geometric sequence. Okay, so if you don't know if this is a geometric sequence, the difference being between this and a arithmetic sequence, to find a geometric sequence, the next term you can find by multiplying by the same number each time. So what times 1 gives us 10? Well, 10. And 10 divided by 1 is 10. Okay, what times 10 gives us 10 to the 2? Well, 10 times 10 gives us 10 to the 2. And you can also say, well, 10 to the 2 divided by 10 to the 1 is equal to 10. Okay, or 10 to the 3 divided by 10 to the 2 is equal to 10. So that's our ratio, our common ratio. R is equal to 10. Okay, we're going to use this formula since this is a geometric sequence. We're going to use this formula. Our a sub 1 is equal to 1. And our a sub n, this time, we're actually going to write, it's going to be our last term. In this particular problem, we're looking for number of terms, okay? So we know our last term is 10 to the 90, so we'll say that this is our last term. We just want to know what term is it, okay? So a sub n is going to be equal to 10 to the 90 power, okay? So I say I have 10 to the 90 equals a sub 1, which is 1, times r, which is 10 to the n minus 1, okay? So 10 to the 90 equals 10 to the n minus 1. Okay, so since they have the same base, you can set the exponents equal to each other, and that will give us n is equal to 91. So how many terms are in this geometric sequence? There are 91. Okay, let's try another one. Let's say I have this 1, 4, 16, 64, 256, dot, 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 and our last term will be 65,536. Okay, so is this geometric or arithmetic? Well, let's divide each term and see if we get the same. So 4 divided by 1 gives us what? 4. 16 divided by 4 gives us 4. 64 divided by 16 gives us 4. So this is geometric. Okay, so since it's geometric, we have a sub n is equal to a sub 1 times r to the n minus 1. Okay, so our a sub n, just like last time, is equal to 65,536. That's our last term. A sub 1 is equal to 1. And r, our common ratio, we found it, it's 4. Okay, so we get 65,536 equals 1 times 4 to the n minus 1 power. Okay, so 65,536 is equal to 4 to the n minus 1. Now, how do we find n? Okay, so there's a couple different ways to go about this. We could just start saying, okay, well, if we've got 65,536, what power of 4 is that? Assuming that it's the same here, we could say what power of 4 and see if it works out nicely, which it should. That's one way to do it. Another way I'll show you in a second is using natural logarithms. But for now, let's see. 4 to the, let's say 4 to the 10 power. That's way too big. 4 to the 8 power. There it is, 65,536. So we can rewrite this as 4 to the 8 power is equal to 4 to the n minus 1 power. And then you can say 8 is equal to n minus 1 since the bases are the same. So n is equal to 9. Okay. The other way of doing this without the guess and check method, and if you don't want to hear this method using natural logarithms, you can stop the video now. But there is another way to figure out this equation. 65,536 equals 4 to the n minus 1. Okay. You could take the natural logarithm on both sides. So ln of 65,536, and it doesn't have to be a natural logarithm, could be a regular logarithm. I just like working with natural logarithms, equals ln of 4 to the n minus 1. Okay, the reason I use the natural logarithm is because there's a rule when you use natural logarithms that say you can take this exponent here and you can kick it out front like this. Okay, so this becomes ln of 65,536 equals n minus 1, oop, that's in the sun there, n minus 1 times ln of 4. Okay, the exponent's gone now. Okay, so we're solving for, still solving for n, so I'll just divide this over to the other side. ln of 4 over here. Okay, so I will get whatever this is equals n minus 1. You can go to your calculator again. The little ln button is right here. ln of 65,536 divided by ln of 4, okay, equals 8. Okay, so 8 is equal to n minus 1, just like last time, and we get n is equal to 9.